And so before zero momentum frame, 21%, that was 8/3 and -4/3. Collision. Collision in the zero momentum frame, this is now -8/3, +4/3. After zero momentum frame, shift back. Let's do the opposite of what I did right there, so +13/3, +13/3, and then after that frame, and so then it becomes 5/3 and 17/3. That's the way I would solve the problem. But I've presented 3 different methods. I do not care which method you want to learn how to use. Whichever method it is, please make sure you know how to use it.
Where did the 6 in front of the V final come from?
The 6 in front of where?
The top equation.
Oh, this is a perfectly inelastic collision. And the 6 comes from the total mass. Because they stick together, it's now 1. So just the sum of the masses.
And then for the P initial, like the big P, you said like adding them, but maybe on here it says like the negative P final B plus the plus P initial of B.
I have to see your notes. What are you looking for? Oh, so P final.
The P initial, yeah.
So
the P
initial equals P final.
But then the PI, you said that it's equal to the negative of final B plus the initial. Yeah, wrong.
Those are both B.
Yeah, they're both B.
And those are both A. If you get all the initials on one side and all the finals on the other. So if you take, add that to both sides, and then add that to both sides, then you'll have P final A plus P final B equals P initial A plus P initial B.
Oh,
All right, other questions? I'm going to put up a problem, and I want you to work on it. I want you to solve it using one of the 3 methods. And again, don't care, just pick the one that you like the best, or that seems to make the most sense to you, which hopefully is the one you like the best. And I'm trying to get one which has nice numbers. There we go. Several choices here. This is all leading into zero momentum frame. So let's change that like that. That. So I've got a 4 kilogram, a 10 kilogram mass. 4 kilogram mass is going to the right at 6 meters per second. This one's going to the left at 1 meter per second. And just so that we all would have the same answer, let's just make to the right positive. what I'm gonna know if I have a perfectly elastic collision. V4 final equals what? And V10 final equals what? What are the final velocities?
Is that 1 meters per second?
Yes, it is. And the final answer should be integers unless there's a mistake with what I've written down here. So, let's see, assuming that, so 410, so if I have a 4 kilogram mass going to the right at that's not right, at 10 meters per second, heading towards an 8 kilogram mass.
These are the perfect ones?
Yeah, perfectly elastic, 1 meter per second. This is before and after. After the 4 is going to the left at 2 meters per second. And the 8 is going to the right at 7 meters per second. And I'm gonna put one more up. So, perfectly elastic collision. And I've got a 3 kilogram mass going to the right at 4 meters per second. 6 kilogram mass going to the left at 5 meters per second. Afterwards, 8 meters per second, 6, 1 meter per second. All right, so there's 2 more problems with the answers that you can retrace at. Oh, I really do need to get another sheet of paper here. All right. Because I never assigned master set 7 or 8, or master set 7, so today is the 21st.
24th.
24th. So March 31st, master set 7 due. April 2nd, master set 8 due.
Are you gonna 2 days in between?
Well, I think of it as you have 7 days to do one and you have 9 days to do the other. If you want to look at it differently, that's your prerogative.
Wait, master says 7 is 31st?
Yep.
And then the 8 is what, sorry?
You know what? We'll go with Dominic's interpretation. So next Monday, master set 7.
Mm-hmm.
Homework quiz on 7 on the Wednesday.
So 2 days?
2 days after the master set's due.
Okay, okay. So next week's Wednesday, not
Yeah.
2 days. Wednesday.
Yes,
Okay.
the Wednesday of next week. I apologize.
All right, April
Right.
2nd.
April 2nd.
Second.
And then the following Monday, the 7th, master set 8. And then the 9th is homework quiz 8. So next Monday, master set 7. 2 days later, homework quiz. Following Monday, master set 8. 2 days later, homework quiz 8. And in the meantime,
31.
that's right, we have another 5 minutes,
31,
which I think is enough time to double the number of equations we have so far.
32, 8, and 7, 9.
Any questions at the moment? All right, let's double the equations.
Double.
Yeah.
Put 2 in front of all?
No. Although, I appreciate the interpretation.
Oh, I need to print those out.
All right, so far we've dealt with linear and translational motion. Linear and translational are interchangeable. It's just, I think I typically use the word linear, but if I use the word translational, it just means the same thing. We're now branching into rotational or angular. And again, they are interchangeable. However, tradition has us using one than the other. You generally talk about angular velocity instead of rotational velocity, but they would mean the same thing. And there's an analog. So for example, position is something we've dealt with, and generally X, R, S, so on. The rotational analog of position is angle. And typically, theta and phi are the two that I use the most, but there are other letters that could be used. Displacement is just delta, x, r, whatever you're using for position. And then the rotational equivalent really is angular displacement or rotational displacement. Although you typically don't see that term used in textbooks, but it's delta, theta, and so on. You have a wheel spinning. Through what angle does it turn? I mean, it doesn't ask for the angular displacement, it just says, you know, through what angle would it rotate? Or how many rotations will it make? Velocity, V. Angular velocity. Typical symbol is omega. Acceleration. Want to take a shot at what the angular analog is?
Angular acceleration.
Sorry, I missed what you said.
Angular acceleration.
Yeah. And the symbol, and it basically goes to what is the Greek analog of A? Alpha. Time. What would be the angular analog of time?
Rotation.
Time.
Rotation? Time? Wait, no. Wait, no.
If you're looking at how much time it takes an object to spin around, it's still called time. It's just time. Force. The rotational analog is torque. Symbol is a tau. And I will sometimes refer to torque as G2 kombucha, and I will not explain that reference. Other than, that's the one that I did consider my most obscure reference, but I have had 2 students understand who knew that reference. Squeeze in here mass. Now, the rotational analog of it has two different names, and I tend to call it moment of inertia. Although some textbooks will call it rotational inertia. Not as big a fan of that term. But, and the symbol for it is a capital I. So notice, typically we have Greek letters for the angular stuff, and then Latin letters, our American letters for linear stuff. But it's not 100% because capital I. It is not a vector, just like mass is not a vector. All right, so when I said double the number of equations, this is what I meant. Take any of the equations. I'll take one of the cake formulas. So I've got delta x equals VIT plus 1/2 AT squared. To get the rotational version of it, just put in the analogs. Instead of x, we have theta, so delta theta is equal to omega I t plus 1/2 alpha t squared. Done. We'll take Newton's second law, F equals ma. The rotational analog, well, force goes to torque, mass goes to the moment of inertia, and A goes to angular acceleration. K equals 1/2 mv squared. What do you suppose rotational kinetic energy is?
1/2 initial inertia, or the moment of inertia. W thing.
Omega.
Rho, omega squared.
Yep. Now I'll leave you with this thought. One of the reasons why I had you know 1/2 mv squared is I said that does not change. That is the formula for kinetic energy. You're working on your Nobel Prize winning dissertation, 1/2 mv squared. And yet here I'm presenting another equation. So I will tell you, it has 1/2 mv squared built into it. This is just a shortcut. If you want to start with that 1/2 mv squared for something that's rotating, well, where not everything is traveling at the same speed, you have a lot of time on your hands. But we'll connect that at some point. Have a wonderful day.
Does that,
Yep. That looks like them.
doesn't make me remember his torque, so